Ladies and gentlemen, welcome to Note 3.3, Equations with Variables on Both Sides. This is for the Math 8 class. The goal for this video is for you to be able to solve equations when you have variables or letters on both sides of the equals sign. What I would like you to do in this video is to circle any questions that you're unsure about when I'm going through these, and please ask at the beginning of class when I see you next. So let's get started. The directions say to solve the following equations, and so number one, what we have is 2m minus 2 equals 6m minus 4. So what I'm going to do is I'm going to reference our flow chart that we've been using in class that is in the notes packet. We're going to follow the same procedure that we've been following in class, and so right here's our flow chart. The first thing that we have been looking at is, are there parentheses? In this case, the answer is no. Move down. Can you combine like terms on either side of the equation? The answer in this case is no. Are there variables on both sides of the equation? In this point, we have yes. It says move them to one side of the equation using inverse operations. So let's do that right now. We have 2m on the left of the equals and 6m on the right. It does not matter which side we move the variables to. What I'm going to do is I'm going to go moving the smaller of the two variables. I think moving something smaller is easier than moving something larger. So let's actually go through, and this is a positive 2m. Use the inverse, negative 2m. So negative 2m, or subtract 2m, both sides. And this will cancel, leaving you with 0. We bring down our negative 2 equals 6 minus 2 is 4m. And then we bring down the negative 4. Now back at the flow chart, we have the next step, which it says, is there a number or a constant not attached to the variable on the same side as the variable? And in this case, the answer is yes. It is this negative 4. Use the inverse operations. So the inverse of subtraction is addition. So add 4 to both sides, and the 4's will cancel. We bring down negative 2 plus 4 is a positive 2 and equals 4m. Okay, and back on the flow chart, we did move, let's see, we moved to the other side of the equation. We're using inverse operations. Last question, is there a number attached to the variable? And yes, the answer is yes. The 4 is attached to the m, and so we use the inverse operations to undo this. It is multiplication, so we will use division, and be very careful here. The m is going to be 1 over 2, or 1/2. 2/4 reduces to 1/2. If you would like to write that as 0.5, that is okay. Now I want to make sure that you could, you know that you can write this as m equals 1/2. The m can go on either side of the equal sign. You can just flip the whole answer that we got in the first place. What I want to do now with number 2 is make sure that your equation is the equation I'm writing down right now. 3x plus 2 equals 4x minus 5. I want you to pause the video at this point, and I want you to solve this on your own, and then I would like you to unpause it and check your answer with mine. Okay, welcome back. What I would like you to do is make sure that you have either 7 equals x or x equals 7. Please pause right now and make any corrections that you need to based on the work that I have shown. So let's scroll down to question 3. Looking at question 3, the first thing I notice is there are fractions. There are 2 ways to do this question. The first way, I'm going to move everything to one side, all the variables to one side and the constants to the other. The second method I will use is going to be to get a common denominator, and you'll see what I'm going to do with that in just a moment. But what I'm going to do is I'm going to decide to follow the flow chart again. The first step would say that there are no parentheses. The second step would be there's nothing to combine on either side of the equal sign. We are going to work our way down to the idea that are there variables on both sides? The answer is yes. So we're going to move the variables to one side. I like to move the smaller of the two variables. So the smaller is negative 1/6 n. So I'm going to add 1/6 n to both sides. And what I end up getting is a cancellation of the n's on the left side. I'm left with a 15 equals 1/6 plus 1/6 is 2/6 n. and we have the negative 1 that we bring down. The next step in the flowchart would say, is there something that is not attached to the variable? And the answer is yes, it's the negative 1. So use inverse operations to undo that. And when we do that, the 1s, they leave 0, they cancel. 15 plus 1 is 16, so 16 equals 2 over 6n. Now, what we do have here is something that's attached to the n. There is some division going on here, divided by 6. So what I'm going to do is I'm going to undo that division by multiplying both sides by 6. The 6's will cancel. 6 times 16 is 96, and that's still equal to 2 times n. All right, still trying to get the coefficients so that they are not attached to n. This is 2 times n. I will undo that with division. So divide by 2 on both sides. N will equal, what is this going to be? Going to be 45, and 45 is 90, 48. So we should have 48 equals n. Okay, that was method 1. Method 2, I'm going to do in blue. We have 15 minus 1 over 6n equals 1 over 6n minus 1. Now, what I'm going to try to do is get a common denominator for all of these pieces in the equation. 15 is actually written as 15 over 1. That will be helpful. The negative 1 is actually negative 1 over 1. So I'm going for a common denominator here. These are already 6's. That means I'm going to try to change the 1's into the same denominator. So to go from a 1 to a 6, I would multiply by 6. What I do to the denominator, I have to do to the numerator. Okay? That is going to give me 15, 30, 45, 60, 75, 90 over 6. I still have minus 1, and what I'm going to, 1n, I'll leave 1/6 n as it is. Okay, I have a 1/6 n here, and what I need to do is change this last denominator to a 6, so multiply by 6, and that must happen on the denominator and the numerator, so I'm going to get minus 6 over 6. Since I'm dividing each term by the same number, the answer is going to come out the same whether I divide by 6 or whether I don't. So I can actually eliminate the denominators here. I'm left with a 90 minus 1n is equal to 1n minus 6. So now much easier to work with. We have variables on both sides as we have been learning about working with. I'm going to move them to one side, move the smaller of the two variables by adding 1n to both sides. The 1n's cancel. I have 90 equals 2n minus 6. Okay. I have something not attached to the variable. It's the 6. And so we are going to add 6 to undo the subtraction. We come up with 96 equals 2n. And hopefully you see that at this point over here it is the same. And so undo the multiplication with division, and should still come out to be 48. So either method you want to use is okay with me. Just make sure that you know that this could also be written as n equals 48. So let's look at the last question for this note. The difference with question 4 is that I am actually going to move all variables to the left side of the equal sign instead of the right this time. And the reason being, I usually move the smaller of the variables. In this case, that will be the 4. So again, walk through your flow chart. The first thing that you would have to do is answer the question, are there parentheses? In this case, no. Second thing to ask yourself is, can you combine like terms on the left or the right? The answer is no. Can you find that there are variables on both sides? In this case, yes. And so that's where I'm going to begin on the flow chart. Like I said, I'm going to move 4w, and when I say quote unquote move it, I'm really talking about eliminating it. Use the opposite of the positive 4, which is a negative 4, and what you do to one side you do to the other side. 9 minus 4 is 5. W plus 3, and make sure that you don't forget that is a negative 9. Most common error that you could have in this problem would be forgetting to bring the negative down. All right, your next step would be, is there something that is not, that is not attached to the variable, and that is the 3. It's a plus 3. We're going to undo this with the inverse operation of addition, subtraction. So 3 plus negative 3 is going to be 0, so you have 5w. 5w equals negative 12. The last step in the flowchart asks, is there anything that is attached to the variable? Yes. 5, it's attached by multiplication, so we are going to undo that with division of 5. And so the 5s will actually leave you with 1w or just w. And we're going to have to leave this as negative 12/5. There is our answer. Again, if you have any questions, I hope that you've circled the questions on this note. I will take those questions at the beginning of the next class. I will see you next time.